don't know me, I'm Christina Samodulski. Thank you all for coming. I'm nervous. You're all hyped to see what I'm going to show you. So I guess we'll just start. So my senior design project was an Android application developed for rehabilitation wheelchairs. I worked in conjunction with my industry advisor, Ben Rounds, who's here in the red, and with my advisor, Mike Otis. So first I'm going to talk about the industry that I worked with. The company's called Curtis Instruments. They're located in Mount Kisco in Westchester County. What they do is they develop motor speed controllers, battery measurements, all sorts of tools for electric and hybrid vehicles such as golf carts, forklifts, and in my case, for rehabilitation chairs. Just a little disclaimer, since I did work with this company, I do have secret information I cannot share with you. There will be some things that you might have questions about that I might not be able to answer. Just a little disclaimer. Alright, so the initial objective was to develop an Android app that would let wheelchair users comfortably and easily use their smartphones. There was some confusion where my project was using a smartphone to control the wheelchair. That's not safe. It's just something that the FDA would probably, or not the FDA, the safety regulations would not allow for a smartphone to control a wheelchair. So we did it the other way, where the wheelchair, you can easily access different functions of your smartphone with just the wheelchair joystick. It's going to implement the QLogic drive control system, which is used by Pride Mobility Products Corp. And like I said, it's developed in conjunction with Curtis Instruments. Alright, so initially we just wanted the app to make basic phone calls and to send text messages, anything that someone confined to a wheelchair might need to do in an emergency situation. Just have that accessibility that people who are not disabled have. It's a luxury we all take for granted. The meat of it, the brain behind the project, is that it's going to utilize a human interface device, which is going to be controlled by the joystick. We'll get into that in further along. So a little background about Bluetooth. It operates in a short range, so you can use it very close, which is why we chose it for the wheelchair. It operates in a specific frequency. All devices that work in radio frequencies are designated to a specific bandwidth. They're only allowed to operate so there's no interference. So in this case, it operates between 2.4 and 2.485 gigahertz, and that's the standard, the IEEE standard for that. So like I said, it's a wireless connectivity. It's also inexpensive. You could buy Bluetooth chips online really cheap for your own projects at home. It's an automatic connection for Bluetooth devices to see that they are in range of each other. You as the user do not have to do anything. They automatically find each other. Also, the Bluetooth 2.1 that is used in the wheelchairs that we're working with, it inhibits MITM attacks, man in the middle attacks. So that means it's a secure connection. There's this thing called bluejacking, where people can basically hack your connection and send, if you have a Bluetooth connection to your phone, people have been known to send text messages from your phone that really aren't from your phone. Someone's able to break into the connection. So this version inhibits that. So basically Bluetooth, all the Bluetooth devices in this room right now are trying to communicate with each other. They might not be connecting, but they're able to see that they are there. We're all within 30 feet of each other, which is the range of Bluetooth. That's why it's a short range. And also what's great about Bluetooth is it uses really low power signals. So in the case of a wheelchair that's run on electric power, you're not wasting a tremendous amount of energy trying to make these connections. So now once your Bluetooth devices have noticed each other in the personal area network, they find devices that they can connect to. So my smartphone might be able to connect to my Bluetooth keyboard. They find each other and they address each other. They match addresses, the media access control address, and they say, okay, we can connect. certain devices can't connect, but once they agree that they can connect, they form a piconet, which automatically occurs. It's nothing you have to do. Once they decide that they can, send data to each other, they use this thing called frequency hopping, where within that specific band range I mentioned, they move between frequency at 1,600 hops per second. So that way, if other devices are communicating, it doesn't interfere because they're constantly switching their frequencies. So back to the brain of the project, the HID interface. The human interface device is something like a keyboard or a mouse, because you as a human, you are inputting the data, and that's what's going to be used to send the information from the wheelchair to the phone that's going to manipulate the device. The other connection that we're going to discuss further along is called SPP, Serial Port Profile Protocol, and what that basically is it replaces the RS-232 connection. Like, it's basically you had a cable between my cell phone and my computer, and I took it out. It's a very specific connection, whereas a human interface device like my Bluetooth keyboard, I can use with any one of your smartphones in the room. So the QLogic enhanced display that is on the Pride Mobility chair that we're using, it utilizes the Blue Giga WT12 chip, and that's just the Bluetooth standard that we use. So what's happening within the chair while the app is being used? The chair is acting as the HID keyboard. It's sending keyboard commands out that are being received by the phone. So you can hook up a Bluetooth keyboard, like I said, to any one of your phones, and an up button is going to do the same thing on your phone or as my phone. It's a very generic application. And each joystick movement is set to a specific command from the keyboard. So you're going to see our protocol for the HID is when you move the joystick forward, it translates into an up button press on your Bluetooth keyboard. Backwards is down, left, left, right, right. And we also were able to include these buttons, which you'll see on the wheelchair, where button click is an enter, where one button click is an enter, one is an escape, just as if you're entering into an app or exiting using a Bluetooth keyboard. What's also great about this wheelchair is it already takes into account the fact that people using it might not have fine motor skills. So it automatically takes in that error and makes it easier to control. And with the button clicks, you don't have to make special commands like hold left for a long time to count as a click, or hold right for a little bit longer as a click. You have separate buttons, which are easy to use. You can use it with your elbow, and they're big. So when we first started the project, it was a question whether to go with Android or iPhone. Everyone has an iPhone. Who has an iPhone? Lots of people, yeah, I know. However, as you can see by my graph, while iPhones are all over the place, you can only use iOS, which is the operating system on iPhones, on iPhones. Whereas Android operating systems, you can use on your Samsung, you can use on your LG, you can use on your Nexus, you can use it on a broad spectrum of devices. It's in tablets. So we decided to go with a broad, where we could help more people with less work. So getting into the programming, we used a program called Eclipse, which I'm sure you just heard about in the last presentation. It's an integrated development environment, and it allows you to program for the Android. You can test it, you can build it for different versions of Android using the SDK manager, the software development kit, and also the Android virtual device, which is basically, I'm going to show you a picture. It's a virtual smartphone on your computer. So this is an image of Eclipse. It's really well organized. It's easy to navigate. What you can do with it is when you're building your app, you can place buttons within the graphic layout and it will generate code for you. You do have to do some manipulation as far as getting text to fit, or if you want it to fit for both a smartphone and a tablet, you have to adjust some settings, but in general, it's fairly straightforward. I learned it by reading a book. So The SDK manager, what the SDK manager does is you update it all the time. And what it does is Android provides kits for development that allow you to test different phones, different platforms. So each kit, let's say you have one phone, it has this kind of camera. These SDK kits are made so when your emulator reads it, they know what phone you're using or what it needs to provide for. It also includes Google APIs, which when you're using Google Apps on your phone, it automatically helps Eclipse know how to program for them. And here's a picture of the AVD manager. You can set it up, you can choose your platform, whatever you want to use, your different API levels, what you want available, what target Android you're using, and it will generate an Android right on your computer. So the final app, our initial functionality we wanted was just to make phone calls and send text messages. However, we quickly realized that you can expand it to do so much more. You can send emails, you can browse YouTube, you can look at your pictures. It links to all different functions within the smartphone that anyone would want to use, whether you're disabled or not. So on the phone, of course, you can do text messaging, you can make phone calls, you can look at your call log, you can navigate to your favorite contacts. And on the tablet as well, which we'll show you works on both the phone and the tablet, you can do everything that the phone can do that's not using a telephone. You can browse the web, you can adjust settings, which will be the next step in the development. So here's some images of the final app. As you can see, we have settings on the bottom, which we set up basically using the graphic layout. We can see this before we emulated it. We have media settings, phone settings, messaging, and web. And using the joystick, you're able to tab or sending a left or right keyboard click through these tabs. And using an up, you can go up into each screen and open whatever you want. And to do that, we had to pull intents, which basically say, hey, once this button is clicked, this has to happen. And then using the buttons, you can go into it or out of it and continue navigating through the entire app. You never have to leave this app in order to do what you want to do on your smartphone. So, of course, we had some troubleshooting issues, just like any senior design project. Initially, my goal was to make it so the app itself had its own Bluetooth connection manager. Quickly realized Bluetooth is a really difficult tool to learn to program quickly in Android. There are professionals who still have trouble with it, and we've recently been working with Dr. Nydia, who I don't know if everyone's met her. She's great. She's from Motorola. She's been in a few times. So she's been helping us with that. So at that point we realized we'll just have to stick to the native Bluetooth connectivity component within your phone, which makes it a little bit more difficult for the user because they have to go outside the app to connect rather than the connectivity manager being inside the app. Programming in Java. I think I took a Java class 3 years ago, so it was hard to catch back up. However, Eclipse also made it really easy, and Android's open source. So when searching how to program certain intents, it was accessible on the internet. It was accessible in books. There were a lot of resources out there for you to use. GitHub is a great resource. You can post code and people can comment on it or edit it. You can use other people's code. So it wasn't too bad, but Java's not my favorite language. Also, in connecting, it took us a long time to realize what exactly was causing the chair to connect to the phone sometimes and not others. And I'm going to go into this in the next slide. But we had a little trouble understanding why there are different firmwares that are used within the chair, and each one does a specific operation or uses a specific HID. So we had to work around that for a little while. And one last thing we found out last night, Jelly Bean. Some Google intents don't work on Jelly Bean. It's just a bug in the system that they haven't worked out yet. Jelly Bean's the latest operating system for Android. So we were working with Ice Cream Sandwich for a long time, and as soon as Jelly Bean came out, of course, we were eager to update and check out the new features, but kind of messed us up last night. However, we got everything working. Let's hope. Connecting to the app. So like I said, there are two HIDs. You can have, like a mouse, that connects you probably used a Bluetooth mouse on your computer at home, or we've actually been able to set up a mouse using the wheelchair on your smartphone. And there's also, the keyboard. However, with the keyboard, as you know, when you connect, you have to select, there's a PIN number. Have you all seen that, where it says enter the PIN on the keyboard to connect? However, when you have a wheelchair, you can't put in a PIN number. So the first step to connect to the phone was we had to use the first firmware, which is called the E305 firmware, and connect as a mouse. We were successfully able to connect the smartphone to the wheelchair as a mouse. Then the process was to switch the firmware to the firmware that included the keyboard HID. So each firmware had its own HID. Firmware 305 was a mouse in order to connect. The next firmware developed was the E311 and the F311. Those had the keyboard. So to kind of make it work, we had to first connect. It was a process to figure this out. We had to first connect to the smartphone using the 305. So once it was paired and connected as a mouse, switching the firmware was easy, and then we could recognize it as a keyboard because it was already connected. So that was the biggest issue. But however, the keyboard HID within the firmware, it's not generic enough. It's specific to how it talks to each phone. Whereas I take this Bluetooth keyboard, I can connect it to any of your phones, no problem. For some reason, the HID within the chair cannot connect to every phone like this can. It's very picky. We've been able to connect it once or twice to a smartphone, and then it never happens again. So it's an issue within the firmware that will be the next step to developing this application. So as I said, what we want to do is develop the Bluetooth connectivity manager within the app. So you no longer would have to leave the app, use the phone to connect to whatever device, and go back into the app. The app can always be on the person's phone, and it'll be in front of them. They can connect, disconnect, connect to different devices, go back and forth. That's within the quick user pairing and connection. So like I said before early on, the SPP protocol, which is basically removing a physical link, it's very specific. That's what we're going to have to do to the firmware in order for each chair to always connect to a device. So it automatically sets up that serial connection and communicates as it should. And then what other things we want to do is just improve the intents. Like I said, we had problems with Jelly Bean. For some of them, like the email inbox and the send email, they're still not working as they should. So we were able just to pop up a message on the tablet and say, hey, this isn't working, sorry. But we want to, at some point, improve that to a point where all the intents we want work properly. And that also little things as far as graphics we want to improve. We want to throw in, our own graphics into the app. We're going to get graphics that Pride Mobilities wants to use in their new enhanced display, which is what sits on top of the wheelchair box. Oh, also I forgot to mention, this is the box that I had to test on. It's basically a wheelchair in a box. It sends out the same code, the same protocol that the wheelchair does in real life, and I can update firmware right from my computer. It's like a factory in a box. So we just want to fix intents. There's some issues with tabbing as far as on a smartphone. If you tab up all the way, it loops back down, but however, if you start in the screen and go back down to that main tab, the main tabs on the bottom, it won't go. You have to loop around. So just little bugs to work out. So of course, engineering constraints. We wanted to provide those with disabilities with an equal standard of living. Those who are confined to wheelchairs, you would think using a smartphone, everyone can do it, but not really. This will enable people who not only can't use their, don't have fine motor skills, but people who have no motor skills and have to use the head array to control their wheelchair. This will allow them, anyone, to use a smartphone the way you and I do. Safety, in a situation where you're in a wheelchair. Recently, actually, someone was trying to do hardware and it shorted out, and they were stuck. What if you get stuck somewhere and you can't access your phone, or you don't have the dexterity to reach around? It can always be in front of you and always on, and you can easily make phone calls. Also economic, of course. This app will be free to users. It's not something, it's to improve a lifestyle. It's not to make money. We want to make it so everyone can use it if they want. Of course, environmental. It's an electric wheelchair. We're using low power in the Bluetooth to keep it electric. And of course, we need to satisfy both my deadlines and Curtis's deadlines, as well as Pride's. Everyone, you know, that's what an engineering project is. You have deadlines. And one of the issues that we faced was with the firmware. However, while they're working on improving the firmware, there's still more that we can do. And we were able to continue and finish the product, even though they didn't meet their, you know, it's a give and take kind of project. And of course, design, working around all the connectivity issues. So basic timeline. Of course, first we started just learning how to use a clip, how to build an app, how to make it look the way we want. We learned finally how to, now that we have it the way we want it to look, how do we get the wheelchair to tell it to do its function? How do we get it to navigate? How do we get it to select different options? And then of course, final testing and further development and suggestions. So in conclusion, this project, while some senior design projects use a lot of hardware, you see chips, you see wires, you see boards, you see motors. This is a project that really used modern new age technology. Engineering is becoming more software oriented, more about your smartphone and your Bluetooth and your GPS. So this kind of brought a whole bunch of things together. You have protocol that's being sent, you have a wireless connection, you have smartphones, your app building. It brought a lot of things together. We surpassed our initial functionalities. We initially only expected to be able to make phone calls, send text messages, but now we're able to send emails. You can find your location on a map. You can watch YouTube videos. You can look at your pictures, listen to music, and that's it. So ultimately, it was a really successful project. There were a bunch of bumps in the roads, but the overall goal of connecting with an HID profile was successful. We're able to control our phones with the keyboard protocol, make phone calls, and do what we were expected. So we're going to have a demonstration real fast with both a smartphone and a tablet, but first I need to say a few thank yous. I'm going to thank my advisor, Mike Otis, for helping me out with this and keeping me motivated. Dr. Nydia, who can't be here, she's very busy. Very busy. I'm going to thank Ben Rounds for being my industry advisor and being my connection between Curtis and my senior design project, and Richie McFarland for helping me out and providing all the equipment for me. I didn't have to pay for anything, which was really great, and that's really what a senior design project should be. It should be students working within the industry and getting involved, so when they come out, they can say, hey, I did something for a company, not just for a science project. And so I really thank you for that. And also the rest of the staff and Dr. Azadi for motivating these kinds of projects. So, any questions? No?
I have a question.
Thanks, Dad.
I just got a smartphone last week.
I know you did. It's awesome.
And I'm not really sure now. I just want to get something straight now. You developed the app itself?
I wrote, yes, the app itself is written by me.
Okay, and you use that JavaScript to write the app?
Yes.
Is that what you use
It's
to
a
write
programming language.
the app? And the app is on the person that uses the wheelchair. It's
Their
on
cell
his
phone. Yes.
It's on that phone.
Yes.
And the wheelchair has a Bluetooth chip in it?
Indeed.
Is that it?
That's it.
Designed into the wheelchair?
Yes, it's built into the wheelchair.
And so that Bluetooth chip communicates with the app?
Yes, it sends signals.
Is that what's going on?
That's it.
And the controls on the wheelchair,
You know, you're doing so good. You're so quiet.
the controls on the wheelchair,
The joystick.
right, the joystick, is kind of hooked up to the Bluetooth chip in the wheelchair.
Right, and that sends the
communicates
signals.
to the app
Correct.
on the guy's smartphone.
Yes.
And so that's how he's able to write text messages and
Right.
stuff.
Now that he's verified everything, does anyone else have
That's a
any
good
questions?
summary right there, actually.
Yeah, thanks, Dad.
That's
Thanks to my parents for coming, and to everyone else in my party over there. All right,
All
are
right,
we
let's see if it
ready?
works.
Okay, thanks, Dad.
Here it goes.
Oh, that's funny.
You want to see
All
you
right,
wasted
can
all
I,
this money?
Dad, would you like to volunteer? Dad, you wanna volunteer?
Yes.
Come on up. Come on down.
This might go real bad. They treat it good though.
You don't do a wrench, she fails, you know.
All right.
I have to pay for this course again?
All right, so this is my app. It's called the QLogic app. So these are your select and your escape buttons. So now to open the app, hit select. Boom. Entered the app.
Wow.
So now, using the joystick, you can move right and left. Keep moving. Oh, this might be on top. Move down. Yeah. See, now you're up here.
Oh, I see.
So if you want to open something, see how it's highlighted? See now
Yeah,
you're
like,
there.
okay, no.
See now you're down here. You're moving.
Oh, right.
So if you want to go up into here, you can move up. He's navigating through the different screens.
Uh-huh. So what if I want to write a text?
So go up.
Not
You
while I'm
can't.
driving though.
This is the tablet, so you can't write a text. But what else? What can we do? If you want to look at your pictures, we'll show everyone the pictures.
Okay.
So go up, go up, go up. Now go left to media. There's a media tab, and you're gonna hit select. And now you're gonna go up to gallery.
Select.
Oh, did we not put pictures on the tablet?
I think there is, but there may be,
They might be like weird testing
no,
pictures.
I mean, yeah. I think there's Raspberry Pi.
Go up. Yep,
Um,
keep going up to
I'll
gallery.
skinny guy from Pride.
Now hit select.
Oh, really?
Up,
I think so, yeah, I saw it in there.
Up.
Yeah, I was like, I better delete that, I forgot.
It's not gonna let you.
No.
No, because there's no stop. You messed up.
Start over.
We can start over. If that's what you want.
Yeah, start over.
Okay. Okay, Dad. You wanna go to YouTube?
Okay.
Go up.
Yeah, connect to the internet, I don't know if it's connected to the internet.
This has 3G though, right?
Oh, does that have 3G?
Yeah.
It does. Oh.
You're gonna go right to the YouTube. Now hit select. And it's gonna bring us to YouTube. It's going. Internet's slow. But, oh, it says web page not available, not on the internet.
Yeah, I think you gotta connect to the.
But, does everyone get the picture?
Yeah.
You can connect.
That's the reason.
But where is the guy's cell phone gonna be like? Like where?
Yeah, we didn't
how
connect
will
the
they-
tablet through the Sony thing.
We're not sure
We have
yet.
to put it
Not sure
logged
how
in.
you gonna hook it up to.
No, it'll probably have some sort of dock that will be right in front of them. I mean, this is still phase one, kind of,
Right.
They have mounting devices too, like for your car.
Right,
You could
that you
mount right
can-
to the chair and it would just sit there.
but it will allow your phone to be
But
right here.
That is pretty good source of everything for him, then, you know, like stimulation, just stimulation wise, you know.
Yeah, look stuff up.
For somebody, you know, like he just doesn't have this. if
Watch
he's-
Netflix.
Yeah, like, I mean, even if he's just hanging out, you know, and.
Or her,
Yeah.
or she.
Or she. They can watch
I know we're
YouTube
engineers,
videos.
but
Am I done?
you can be done, yeah, thank you.
Thank you.
Thanks for the participation. I think he got a bigger round of applause than I did,
Good question.
so if you wanted to see phone utilization using the keyboard, since it doesn't work fully with the wheelchair, you can make phone calls. Anyone have their phone on? We'll test
I
phone.
do.
You have your phone on?
Phone's supposed to be silent, or is your phone?
Yeah, right.
Oh no, this froze. It disconnected. It was asleep for too long. Never mind. Phone's not gonna happen. But we'll set it back up and we'll have it for later too. And we can call each other and go crazy. So yeah, that's it. All right, who's next? You want my dad to